Hey everybody, we are moving on. We are moving on to some other quadrilaterals. We've spent a lot of time with parallelograms, so we've got a couple different kinds of quadrilaterals coming up today that are not parallelograms but have some interesting properties, okay? So we'll be talking about trapezoids and kites. We got a bunch of vocab. We'll talk about trapezoids in the various parts, what's an isosceles trapezoid, and then midsegments, and then get into kites. This is coming out of our text section 6.6. So let's get her going. So a trapezoid is a quadrilateral with one pair of parallel sides. Clear enough? So as opposed to a parallelogram which has two pair of parallel sides, now we only have one and the second pair is not parallel. It's got different parts, all right? The two parallel sides are called bases, and the non-parallel sides are going to be called legs. So parallel sides, bases, non-parallel sides, legs. All right. Now, we refer to the angles. Obviously, there are four of them, but the angles that line up next to a base are called base angles. Okay, so one set lines up here and here with the top base. One set would line up here and here with the bottom base. Those are the base angles, two sets. All right, and the reason that's important is because when we get into the properties of isosceles trapezoids, we're going to find out something here. All right, that is, an isosceles trapezoid is a trapezoid where the legs are congruent. Okay, so this leg and this leg would be congruent, and what that means is that each set of base angles is congruent to one another. So here are the set of, on the bottom, this set of base angles, those two are congruent to one another, as are this set of base angles. Obviously the four are not congruent to one another, but each pair is congruent to itself. So here, those are congruent. Meanwhile, the top ones along the other base are also congruent. That's theorem 619. If a quadrilateral isosceles is an isosceles trapezoid, then each pair of base angles is congruent. All right, so should be fairly easy for you here, I'm hoping, as long as we remember one important thing, and that is this. We've got parallel lines and transversals, and we need to remember what we know about same side interior angles. Well, that should give us everything we need to know about the angles on these two sets of isosceles trapezoids. So answer's coming in a second, but I think you already got it. Here we go. All right, that one's got to be 64 since base angles are congruent, and since same side interiors have to add up to 180, these two both have to be 116. Same thing's happening here. You got a 108 and 72s. Good enough. All right. Ooh, nice little fun exercise here. I got 36 wedges, and this part here, let's go with this. Let's write something down here. Okay, so each one of these little segments is made of an isosceles triangle, and each one of these and these are made of isosceles trapezoids. The question is, find x and y. Okay, answer coming on the next slide. Pause if you want. We're going to hit go when we're ready. All right, so knowing there were 36 of them, and they had to make up an entire circle, right? That has to be 360 degrees. Therefore, each one of these must be 360 divided by the number of wedges, 36. Each one of these has to be 10 degrees, angle A. Okay, so therefore if the vertex angle of an isosceles triangle is 10 degrees, we know these two, since it's an isosceles triangle again, have to be congruent, and those would make whatever's left out of our 180 to form the triangle. That leaves 170, means each of these must be 85. All right. Okay. Now, since we have a linear pair right here, okay, that means y must equal, what does that leave? 95, right? To add up to 180 to make the straight line here and here. All right. Now, isosceles trapezoids, x also has to be 85. Okay. And by the way, this has to be x, this has to be x, this has to be x. Okay. This has to be y, y, and y. So this is how we would solve the wedge problem. Okay, and you can read along if you need a little more detailed explanation, okay? Now, moving on. Another important thing about isosceles trapezoids. Okay, theorem 620 says if we have an isosceles trapezoid, BC are parallel, AB is congruent to CD, then our diagonals are congruent. Okay, theorem 620. Finally, trapezoids have midsegments as well, all right? If we have a trapezoid, now this isn't necessarily an isosceles trapezoid, these two sides do not have to be congruent. But if each of these is bisected, in other words, this is a midpoint, and this is a midpoint, what we have here is called a midsegment, okay? So a midsegment of a trapezoid is one that connects, is a segment that joins the midpoints of the legs. And the properties that we need to know about that are covered in theorem 621. All right, if the quadrilateral is a trapezoid, then its midsegment is parallel to both bases, and its length is the average of the two bases, or PQ is 1/2 of the sum BC plus AD. Okay? So make sure you know that. In fact, I feel like I'm gone really quick on all these, but make sure, because they're pretty important, so make sure you got them down. So midsegment are parallel, and the length is the average of the two bases. Also know, if it's isosceles, then the diagonals are congruent, and also know base angles have to be congruent. Excuse me. Okay, so a little problem for you to work on here. PQ is a midsegment. What is its length? Answer coming. Here we go. Well, the midsegment, x plus 2, has to be the average of the two bases. So there's the 4x minus 10. There's the 8. Those are our two bases. Add them together, divide by 2. And what we'll see is that when we do the math, here I just combined like terms. Do that. Here I combine like terms. That makes a minus 2. And distributed the 1/2 to get this. Okay, subtract the x, add the 1. We find out that x is going to be equal to 3. And that would make sense. We plug them in. We find out this is, if x is 3, we got a 12 minus 10. That's got to be 2. That's got to be 5. That's got to be 8. It is, in fact, the midsegment is, in fact, the average of the two bases. Good? All right. Moving on. A kite. Another kind of quadrilateral, but this one, a kite has two pairs of consecutive sides that are congruent. All right? But none of the opposite sides are congruent. That's what makes a kite, and it's fairly straightforward because it, kind of looks like a kite. So, properties of a kite. All right? Theorem 622, its diagonals are perpendicular. Okay? Good enough. Always, for a kite, diagonals are perpendicular. Now, we don't have theorems for a couple things, but you should be able to notice a couple things about it. If we draw a line BD here, notice that we've got one side that's reflexive, two sides are congruent. Triangles here, ABD and CBD, have to be congruent by SSS. And what that tells us is that This angle here must be congruent to this one. This angle A must be congruent to angle C, and this angle here must be congruent to one another down here. In other words, the diagonal that splits the splits the kite between the congruent sides. Okay, well, that bisects the angles, the opposite angles, and those other angles are congruent as well. That doesn't work, by the way, with the diagonal that cuts the other direction, right? We will not have the same kind of property with that diagonal, okay? But it does work for the one diagonal, okay? So angles are congruent, these two bisected, these two congruent from the get-go, all right? Next thing you want to know about kites is that also, we won't go into a huge long proof of it, but this diagonal then will be bisected by the other one. AE will be congruent to EC. All right? So, and again, the reason is it's equidistant from the points. We know that it's got to be on a, if B is equidistant from the points, as is D, they both have to lie on a perpendicular bisector of AC. Okay? So, there we go about kites. Little problem to work on. Pause it. Here comes the answer. Okay, you can go through each of those. 1 and 5 obviously have to be 90. 2 has to be 64. 8 has to be equal to 72 degrees. Whatever 6 and 7 would come out to be 18. You can follow along. Hopefully that all makes sense. Okay, so quick summary. Here's where we've been the last few days. We've learned about all kinds of quadrilaterals. Quadrilaterals are four-sided polygons, okay? And out of all the quadrilaterals in the world, we have learned about 3 different sets of quadrilaterals. We started with parallelograms, and we learned about rectangles, which are parallelograms with congruent angles. We learned about rhombuses, which are parallelograms with congruent sides. Squares, which have properties of both rectangles and rhombuses. Then we learned about trapezoids. One kind of trapezoid is an isosceles trapezoid where the sides are congruent. And then we learned a little something about kites. Now, again, I'm not going to go into too much more review, but folks, please know the differences in the properties of each of these, okay? They're extremely important, so if you need to cover anything that hasn't sunk in really deeply into your heads, you might want to just go through some of these again, okay? So, that's what I know. We will see you next time.